Hello my dear students, hope you all are fine and maintaining the same tempo in learning physics. Today we are going to study projectile motion. What is a projectile motion actually? Whenever an object is thrown in space, it will be in flight for a particular time. After that it will reach the ground. Let me give one example of throwing this. This is an object which is thrown in this direction like this. That means initial velocity is given to the object so that it is making a motion in this direction. If you see the object in slow motion, you will see that object is moving like this. That is, the object is coming to the main point, that is highest point, and getting down after that. So, projectile motion can be written object in space when thrown with some initial speed. That is, object in space when thrown with some initial speed. You will find that when the object is thrown, it is making motion with respect to the x axis and with respect to the y axis. If you consider this as a xy plane, the object is moving like this. Slowly it is getting up and reaching one highest point and getting to the parallel to the x axis. That is called the projectile motion. So, if you see graphically, say this is x axis, this is y axis, we know. If an object is thrown like this, it will start move like this. Okay. So, after attaining some position, it will get down like this. Here the acceleration towards x axis is 0, ax is equal to 0, because it is moving along the y axis only. So, net acceleration along x axis is 0 and along y axis is minus g. As we have already discussed there, whenever an object is moving upward, it is against the gravity. So, that is ay is equal to minus g. Along the x axis it is 0. Now, let us consider the graph as such. An object is thrown from the origin, that is 0, 0, with initial velocity u and projected with angle theta with the horizontal. Let the initial velocity along the x axis is u cos theta and velocity along y axis is u sin theta. We know that acceleration is equal to acceleration along x axis plus acceleration along y axis. Just now we have seen that ax is equal to 0 and ay is equal to minus g. As I have explained, as the body is moving away from the earth, the gravity will be minus g against the gravity, that is why minus g is taken. Along the x axis there is no change in velocity. So, if there is no change in velocity, then the acceleration along the x axis will be 0. Now, from the previous class we have derived the equation of motion. From the second equation, we know that x is equal to x naught plus uxt plus half at square. We know In this case x naught is 0, x naught equal to 0. Further we know Ax is equal to 0. So what we can get, x is equal to, this term is 0 and this term is 0. Ux we have considered that u cos theta. So x is equal to u cos theta t. Let it be equation number 1. Similarly, we can go for y axis also. So y is equal to, that is the position of the object with respect to the y axis, as we have considered here p of x comma y. So y is equal to y naught, similarly y naught plus uyt plus half at square. In this case y naught equal to 0 and ay is equal to minus g. Putting the values in this equation, we will be having y is equal to, this term will become 0, uy in place of uy, that is u sin theta t, since ay is equal to minus g, minus will come here, minus half gt square. Let it be equation number 2. So x is equal to u cos theta and y is equal to u sin theta t minus half gt square. Since we have found the position of the object, we can find the velocity components also very easy. So velocity components, if we have got x, means we can find the velocity along x axis, that is Vx is equal to dx by dt, that is derivative of this, we will be having u cos theta, dt by dt, that will become 1 and we will be having u cos theta. So Vx is equal to u cos theta, that is velocity along x axis. Let it be equation number 3. Similarly, we can find the velocity along y axis, that is Vy is equal to dy by dt. So derivative of this equation, u sin theta dt by dt 1, so we can write u sin theta minus half g into differentiation of t square is 2t. So we can find Vy is equal to u sin theta minus 2 will get cancelled, we will be having gt. So this is the velocity of the object along y axis. Let it be equation number 4. I hope you understood this. These are the 4 equations, these are the 4 main equations by which we can derive all the terms of the projectile motion. As we have derived 4 equations, that is x is equal to u cos theta t, y is equal to u sin theta minus half gt square, Vx is equal to u cos theta, Vy is equal to u sin theta minus gt. Now we need to find the nature of path of projectile. What will be the nature of the projectile? That means graphically how we can represent. We have assumed that the graph is like that, but we have to analyze how and what will be the direction of the projectile. From the equation 1, that is x is equal to u cos theta, that is from equation 1, we can have that t is equal to x by u cos theta. X t is equal to x by u cos theta. Putting the value of t in equation 2, putting the value in equation 2. From the equation 1 we have got t is equal to x by u cos theta. Putting the value, what we will be getting, putting in equation 2, what we will be getting, y is equal to u sin theta t minus half gt square. U sin theta, in place of t we can put x by u cos theta minus half g t square. In place of t, again we will put x by u cos theta square. So, what we can have here is u will get cancelled, sin theta by cos theta is tan theta x minus half, this is square. So, we can write g by u square cos square theta into x square. So, comparing this equation from the generalized equation, that is y is equal to ax plus bx square. If we compare this is x term is there and x square term is there. Making use of this equation, this is the equation of parabola. So, we can write that nature of path of projectile is parabolic. So, nature of path of projectile is parabolic. So, this equation gives us that the nature of path of projectile is parabolic. So, the path will be like this only. So, in the first one we have shown that the path of the projectile is always parabolic in nature. Some of the terms in projectile are given here. We will discuss separately one by one, which are very much important to understand as well as do the numericals also. First one is time of maximum height. We will understand separately. Time of maximum height. This is the projectile and this is the maximum height. Okay. So, the time taken by the object to reach the maximum height. The time taken by the object to reach the maximum height, that is the time of maximum height. It is represented by Tm. What else we can predict here? Here Vy is equal to 0. Again we will consider the same example. If we throw an object, it is going like this. After reaching the maximum height, for a particular time, at that time the velocity along y axis becomes 0. After that it starts falling. The velocity along y axis is 0, but the x axis is not 0. That is why it is having the tendency to move forward. So, at this point Vy is equal to 0, or in other sense we can write the time taken by the object to reach Vy is equal to 0, that is the time of maximum height. Next is maximum height. What is the maximum height? This is the maximum height, that is y axis at Tm, that is time at which it is reaching here, the y axis that gives the maximum height. Simply we can say y axis at Tm. Next is time of flight. If we throw an object for a certain time, the object is in flight. When it is released from the hand and it reaches the ground, so the time taken by the object to travel from the 0 position of x axis to come to the 0 position of x axis, that is reaching the ground. So, the total time taken by the object to reach the ground, or else we can say how much time the object is taking in air or is being in air and y is equal to 0. Because it is reaching to the ground, obviously the y direction will be 0. Simply the time taken by the object in flight. Next is horizontal range. Horizontal range means it is saying about the x axis, that is distance covered by the object in TF time. TF time is the total time taken by the object from the initial point to the final point. So, in the total time, how much distance is covered by the object horizontally, that is distance covered by the object in time TF along x axis, that will give the horizontal range. Now, we shall go for it each terms mathematically. Now, we shall go for the first term, that is time of maximum height, that is time taken by the object to reach the maximum height, that is represented by Tm. As we have earlier discussed, at this point Vy equal to 0. Vy is equal to 0. That means at this point the object's velocity along y axis is 0. So, Vy is equal to 0 we can take. Already we have got the equation Vy is equal to u sin theta. Vy is equal to u sin theta minus gt. So, Vy is equal to 0 means gt equal to u sin theta and t is equal to u sin theta by g, or Tm equal to, we can write u sin theta by g. This is quite simple. So, the time taken by the object to reach the highest point at which the velocity becomes 0, after that it starts falling. So, the time taken is Tm is equal to u sin theta by g. Let us go for next term also, that is maximum height. Maximum height. Maximum height, y axis at Tm, that means the height y axis as the time Tm. So, what we can take here, y is equal to, we know the formula, y is equal to u sin theta t, u sin theta t. In place of t we can write Tm, because we have taken t is equal to Tm, t is equal to Tm. So, u sin theta Tm minus half g t square, that is Tm square. Now, we know the formula Tm is equal to u sin theta by g, we can put the value here. So, y is equal to u sin theta, in place of Tm u sin theta by g, u sin theta by g minus half g u sin theta by g whole square. Again we can have u into u square sin square theta by g. Again here half g u square sin square theta by g square. This g and g will get cancelled. We will be having y is equal to u square sin square theta by g minus half u square sin square theta by g. Taking common, that is u square sin square theta by g, we will be having y is equal to u square sin square theta by 2g. So, this is the maximum height attained by the object at Vy equal to 0, or simply maximum height attained by the body y is equal to u square sin square theta by 2g. Next is time of flight, that is the time taken by the object from the initial point to the final point, that is how much time the object is in flight. So, time of flight, it has been represented by Tf. Here we know that in initial point x axis and y axis is 0, but along this x axis is there and y axis equal to 0. So, we can take y is equal to 0. We know the equation y is equal to u sin theta t minus half gt square, Here y is equal to 0 means half gt square is equal to u sin theta t, and these two t will get cancelled. We will be having t is equal to u sin theta by 2u sin theta by g. Quite simple. In this case y is equal to 0, putting the value y is equal to 0 in the equation we got earlier, y is equal to u sin theta t minus half gt square, we will find that half gt square is equal to u sin theta t. This t and t will get cancelled. We will be having t is equal to 2u sin theta by g. Here one thing we need to note that Tm we earlier found that u sin theta by g, and Tf we found that 2u sin theta by g. What we find here is Tf is equal to 2 times of Tm. So, Tf is equal to 2 times of Tm. So, what we get from here is the time taken to travel the maximum is equal to the time taken by the body to get into the ground. So, both are same. So, this we can take Tm and this we can take Tm, Tm plus Tm 2 Tm. So, the total time taken by the object in flight, that is Tf is equal to 2 times of Tm. Next term is horizontal range. What is horizontal range? The distance covered by the object horizontally, that is in x direction, taking time Tf. So, the time taken here is Tf. So, T is equal to Tf and y is 0, and along x axis we know x is equal to ux cos theta into total time is taken. So, we will be writing Tf here. Okay. So, x is equal to u cos theta into time of flight is just now we have calculated, that is 2u sin theta by g. So, what we can have here is u into u square, x is equal to u square, 2 sin theta cos theta divided by g. We know the formula, sin 2 theta is equal to 2 sin theta cos theta. So, we can put here x is equal to u square sin 2 theta by g. So, this is the horizontal distance covered by the object, that is we can say horizontal range. When it will be maximum, we know that u and g are constant, it solely depends on the sin 2 theta. For maximum horizontal range, maximum horizontal range, sin 2 theta should be equal to 1. So, we can write x max, that is horizontal distance maximum, is equal to u square by g, is equal to u square by g. Moreover, if you want to find the angle, then we know that sin 90 is equal to 1. So, 2 theta should be equal to 90 degree, and theta is obviously 90 by 2, that is 45 degree. So, theta is equal to 45 degree. That is why it is always advised to the javelin throw player to throw the object in 45 degree. If he is throwing the javelin in 45 degree, the distance covered by the object horizontally will be maximum. So, theta is equal to 45 for maximum horizontal range. For maximum horizontal range, when it is maximum, we can have the formula u square by g. Collectively, we have seen all the terms related to the projectile. We will summarize now. Now, we can summarize. We have seen that nature of path is parabolic, that is projectile's path is parabolic in nature. And second is time of maximum height, time taken by the object to reach the maximum point, that is maximum height. Tm is equal to u sin theta by g. Next is maximum height with respect to the y axis, that is y is equal to u square sin square theta by 2g. Next is time of flight, that is time taken by the object being in flight, that is Tf is equal to 2u sin theta by g. Here Tf is equal to 2 times of Tm, that is time taken by the object to reach the highest point is equal to half of the total time of flight, that is Tf is equal to 2 into Tm. Next is horizontal range, that is the maximum distance covered by the object with respect to x axis, that is x is equal to u square sin 2 theta by g. For horizontal range to be maximum, x max is equal to u square by g, since sin 2 theta is equal to 1. Angle for maximum range, that is theta is equal to 45 degree. If we throw any object at 45 degree, it will be having maximum horizontal range. Let us do a numerical to understand the concept easily. A body is projected with a velocity of 30 meter per second at an angle 30 degree with the vertical. Find maximum height, time of flight, horizontal range. So, body is projected with a velocity of 30 meter per second. So, initial velocity is given at an angle 30 degree, that is theta is also given, but with the vertical is given, So, if we draw the diagram, this is the projectile and it is vertical to this, that is 30 degree, but we need to have the angle with respect to x axis. So, obviously this will be 60 degree. Now, come to the question maximum height. So, first one is maximum height. So, y is equal to u square sin square theta by 2g. This is the formula we have discussed. Putting the value, u is 30 square into sin square theta is 60 degree by 2 into 9.8. Further simplifying this, 900 into sin 60 is root 3 by 2, So, squaring the value, 3 by 2 square is 4 into 2 into 9.8. So, simplifying this, we will be having 34.4 meter. So, y is equal to 34.4 meter, that is maximum height attained by the object is say 34.4 meter. Next is time of flight. We know Tf is equal to 2u sin theta by g. Putting the value 2 into 30 into sin theta, that is sin 60, that is root 3 by 2 into g is 9.8. On simplification, these two will get cancelled. We will be having 5.3 second. So, we have calculated total time taken by the object in flight. Next, we have to calculate horizontal range, that is x is equal to u square sin 2 theta by g. Putting the values, u square, that is 30 square into sin 2 theta means 2 into theta, theta here is 60 degree, so 120 degree divided by 9.8. Putting the values and simplifying this, we will be having 79.5 x, that is meter. So, the maximum range, horizontal range covered by the object is 79.5 meter. During this class, we have briefly discussed about the projectile motion. First, we have discussed the path of the projectile, that is parabolic in nature. Next, time of maximum height, that the time taken by the object to reach the maximum height. We have discussed maximum height, that is the maximum height attained by the object at Tm time, that we have calculated. Time of flight is the time taken by the object to the initial point to the final point. Next is range of projectile, that is the distance horizontally covered by the object in total time, that is Tf we have discussed. That is next is maximum range. What is the maximum range? That is u square by g at theta is equal to 45 degree. That is, in order to get the maximum range, we have to throw the object in 45 degree. We have done a numerical also. Hope you all understood the concept and advised to do lot of numericals in this concept so that you can understand it very nicely. Thank you.